Hello everyone. So here we are going to start a video series on recursion, how recursion works and how can we solve problems using recursion and understanding the terminologies of recursion problems. It was very difficult for me at the beginning to approach a problem and bring a recursive solution for that. So I'm here to make the video for people who understand what is recursion but struggle to bring a recursive solution for a given problem. So this video is not something theoretical that explains you all the terminologies and stuff, but I'm here to share my experience on how I did practice recursion problems and how we can approach a problem and bring a solution for any problem using recursion technique. So let's get started. Before getting into practical problems, we have to understand how recursion really works. So first, what is recursion? Recursion is nothing but a function that call itself. So if we have a function which have some value, say integer value n, and if we have another function that calls the same function, then it is recursion. So how does it work? So every time a function encounters calling a function, it is going to put that value to a call stack. We have a function that prints the number. So our integer n's value is going to be 5. It enters the function as 5 and now it encountered the first line which is calling the function itself for the value n minus 1. So when the function any function or method is called, it is going to put or allocate a memory in a call stack. So first it enters print numbers of 5. So once it look at the function calling itself, that is print numbers of 4, instead of executing the rest of the program, it is going to place and create a memory location in a stack and call this function print numbers of 4. So once print numbers of 4 is called, it is again going to enter into the same function. Since the same function again calls print number of n minus 1, which is print number of 3, it is going to call that function. So it is going to again place print number of 3 in a stack, again goes back and calls the same function, and it calls the first function print number of 2. And print number of 2 is again going to call the same function and it is going to call print number of 1, and it goes on and on and on. So here we need to observe the function has no end. It goes on a continuous loop. That is, we started with 5. Since integer values can go beyond 0, minus 1, minus 2 till it reaches the integers, it goes without stopping. So how do we stop a recursive program? So we need to put an end for the looping of the functions by using a base condition. Before understanding the base condition, so now we started our program by print number of 5. So it is actually calling in the first line print number of 4 and then printing the value. So before printing the value, it actually called print number of 4. So here print number of 4 is calling print number of 3 before it actually prints 4. Same way, it called print number of 2 and then print number of 1 and then it stops. Consider it is stopping. So here what is actually happening, since we stopped the program till print number of 1, it first print 1 and then move to print 2. Here it prints 2, that is the rest of the code after calling the function, and then move to the previous function. So here it prints 3 or execute the rest of the code after calling the function and then move to this function. It print 4 and then return back to where it has been called. So every time it finishes executing the last call, it comes back to where it has been called, and then finishing this code, completely executing the code of that function, comes back to where it has been called, and finally reaches the original function where it is all started. So here in this case, to understand what is a base condition, let's go and understand the code. So here we have a main method where n is initialized to 7 and we are printing the numbers. Here our print numbers function is simply looping the variable and printing the number and decrement the number every time so that it finishes and stop at n is greater than 0. So here we are going to use recursion instead of looping the function. So let's see how are we going to do it. So we are going to print the number, that is going to be the obvious thing. So every time we print the number, what are we going to do? We are going to decrement the number. So we are simply going to call the same function and decrement the number. So this is called recurrence relation, which we are going to see further in our video. So before understanding what is the term recurrence relation, let's run the code now. This is not the complete code. So first run the code and understand what we have to do. So yes. So this runs starting from 7. We didn't put an end to calling this function. So this function is still running till the time limit is getting exceeded. It goes on and on and on till it reaches the maximum limit of numbers. So, but the solution we need is we have to stop it by 1 or 0. How do we do it? To do that, we need to stop calling the function. Why it is running so many times? Because every time an n is decremented, the next function is being called. To stop that, we have to add a base condition. Base condition is nothing but something we can arrive at a solution immediately. So here we are going to mention if n goes less than 0, then simply return. That is, we are stopping the method from calling another method. So we put an end to calling the methods. So if n is less than 0, we are not going to call any method, just return from this method and exit the loop. So if you run the code now, it just stopped with 0. So the two things we have to observe here is our base condition and recurrence relation. We are going to see both of them in this video now. But one more important thing we are here to see is the numbers are printed in reverse. I'm just going to change this statement after the method. So I just remove the statement of printing the numbers after calling the method and I'm going to run the code. Now the method prints the number forward from 0 to 7. So how is this happening? In order to know that, we have to understand how recursion works exactly. So now we are yet to understand three terms, that is why it is printing reverse and forward just by changing one statement before and after, and what is a base condition and what is a recurrence relation. As I explained how recursion works, every time it invokes a function, that function is going to call next, that function is going to call next, further it reaches the last function till our base condition. So once it satisfies the base condition, it is going to stop calling the functions and first execute what is in the top of the stack. That is, we saw in our stack, it enters 5, 4, 3 and finally goes till where our base condition meet, that is 1. So it first executes 1 and then finishes its execution and then go back to 2 and then go back to 3 and finally execute the main function it called it. So every time the last function executes first and then come back to the second and then move forward and end up in the first function it has called. So we have wrote our print function after calling the method. So since we called after calling the method, it is going to execute the last method first, and then the last but one method second, and then the first method last. In case if we print the number first and then call the function, it is going to execute this code first and then move to call the function. So though it is calling the function, it is going to print it first and then call the function, so it actually printed in reverse order. So next is base condition. So we all know what is a base condition. That is, for every looping it takes, we have to stop the loop. To stop the loop, we put a condition at the starting stage of the program is called base condition. Or otherwise, for any program, we can derive at the solution for our lowest or the smallest subproblem. For example, take a Fibonacci series, Fibonacci of 5. So how does the Fibonacci series work? It is going to start from 0, and then 0 plus 1 is going to be 1, 1 plus 1 is going to be 1 plus 0 is going to be 1, 1 plus 1 is going to be 2, 2 plus 1 is going to be 3, 3 plus 2 is going to be 5. So it is 1, 2, 3, 4, 5. Fibonacci of 5 is going to be 5. So here we can put any number 7 or 10 or 1000 to calculate our Fibonacci values. But we clearly know the first value of Fibonacci series. That is, if it is a fib of 1, it is going to be 1. So using this condition, we can terminate the loop. That is, we call it n number of times, but to stop it, we can put a base condition. If our number is equal to 1, then return 1. In this case, our Fibonacci code is not going to call the function. Instead, it just return the value and stop the loop. So we can put or say a base condition is something that help us to stop calling the recursive method, or something that we can arrive at a solution earliest for a smallest subproblem. Overall, we can put it one way: a recursion start executing at a bigger picture until it reaches its base condition. So if you're not getting it, you obviously gonna get it in further videos, because we're gonna use the base condition term and the base conditions in every recursive program we're going to approach. Next, moving on to recurrence relation. Recurrence relation is nothing but a relationship between one subproblem and the other subproblem. So here take the same example of printing a number. So if we are printing n is equal to 7, so we are going to print 7, and the next number should be 6, and the next number should be 5. So what is the relation between these subproblems? Considering this is one subproblem, this is another subproblem, this is another subproblem, until it meets the base condition 0. So what is the relationship? It is nothing but the difference is 1. So you can say n becomes n minus 1. So this is the recurrence relationship here. Recurrence relationship is nothing but we use to get the solution of one subproblem from another. So the relationship defining between calling the function itself is called recurrence relation. This is not something that is in books or theoretical explanation of what is a recurrence relationship, but something what I have understood to approach a problem. So we today have seen what is recursion, how does recursion work, what is a call stack, and what is a base condition, and what is recurrence relation. So enough understanding the terms. From our next video, we are going to jump into solving basic problems of recursion using these terminologies, and further gonna solve more tougher problems. So stay tuned and look for the videos. If you like the video, hit like and subscribe. And if you have any suggestion, please do comment so that I can make the videos better next time. So thanks for watching the video. Thank you.